All right, in this video, we want to talk about inverse functions. But in order to talk about inverse functions, we must first start with the idea of what is a function. So a function, let me write this up here. A function is a relationship between two values an input and output for which each input is mapped, or is paired is another word, is mapped to only one output. All right, so that's a big lengthy mouthful of words. So let's look at it from a graphical standpoint because it's easier to see. So let's take a function that looks like this. Or let's not even call this a function just yet. This is just a relationship. There's a relationship between all these pairs of numbers. Okay, so how do we tell if it's a function or not? Well, if we want to check that each x value is paired with only one y value, we don't want to go x value by x value along this graph and say, okay, is this x paired with only one y? Is this x paired with only one y? This x, so on and so forth. We could be here all day doing that. So what we do is we can have the vertical line test. The vertical lines stand for every x value. Like if I was to put x marks along the x-axis, okay, all of these vertical lines stand for these x values. So if I make infinitely many vertical lines, the vertical line test says if each vertical line only passes through the function once, or the graph once, we call that a function. So I'm just going to write vertical line test over here so you know what we're doing here. And this graph passes that vertical line test, so we would say that this graph represents a function. So it satisfies this definition. So before we get started talking about what an inverse function does, we first have to understand the idea of inputs versus outputs for any old function. All right, so I'm going to start with a linear function, and I'm going to let it be defined by this equation. So f of x is the name of our function, and let's let our function be 2x plus 1. All right, so let's see what happens, what this function actually does. So let's look at f of 2. So this is a good review of our function notation. F of 2 says we take a 2 and we input it into our function. So we put 2 in to our function and it should spit out another number according to this rule that says we're going to take 2 times that number and then add 1 on top of it to get our output. So we have 2 times 2 plus 1, which is 5. All right, so we can say that f of 2 is equal to 5. All right, so that 5 was our output. All right, let's do another number. Pick any old number. I'm just going to go with 3. And by the way, I didn't pick 2 for any particular reason. I just chose a number to start with. All right, so 3. What about 3? Well, that would be 2 times 3 plus 1, which is 7. So again, we have that f of 3 is equal to 7. So let's think of it in sort of this way. Let's say we have this thing, and this represents the collection of all the inputs that we can throw into this function. What do we call that? That's our domain. Okay, so what are two things that for sure lie in our domain? Well, we've shown you 2 and 3 lie in our domain. So 2 and 3. And what does the function do with those numbers? Those functions take those numbers and map them or pair them with the output. Then what does this blob represent? This blob represents the range, the set of all outputs of a function. So we take a 2 and it gets mapped to 5. Okay, what does that? What does that mapping? Our function that we called f. So f takes a 2 and turns it into a 5. In the same way, f takes 3 and maps it to a 7. So the arrow just shows what it's mapped to. Okay, it's not like in behavior where you have approaches. This is saying f takes a 3 and makes it a 7. That's what the function does. It takes a 2 and makes it a 5. Okay? So now we have the base idea of what a function does. It takes inputs and pairs them with outputs. And in order to be called a function, each input can only go to one output. All right? So now how does the inverse function play into this? Okay? Well, what the inverse does is it takes your outputs of the original function and brings them back to the inputs. Okay? So we would say this is the notation for an inverse. It's f with looks like an exponent of -1. It's not read f of -1 or f to the -1 power. This is read inverse f. Inverse f takes 5 and turns it back into a 2. Okay? What do you think the inverse is going to do with the 7? If you input a 7 into the inverse, what do you think that's going to do? Well, it's going to turn it back into a 3. So that's the basis of what a inverse does. If you remember inverse operations, what do inverse operations do? They cancel each other out. For example, if you take addition and you pair it with the same number with subtraction, those two things cancel out. We say the same thing happens with multiplication and division. Those are inverse operations of each other. Well, we also have inverse functions, which does the opposite of what a function does. All right, so if we look and think in terms of non-concrete numbers, if we kind of turn it to the abstract and say our domain is the set of all x's, so there could be an infinite amount of numbers inside of our domain, it's going to take each one of those x's and our function f is going to turn the x's into outputs y's. Okay, well let's think about what the inverse does. The inverse takes those y's and turns them back into x's. So it flip-flops the x and the y. So what would that look like? What would the inverse look like of 2 times x plus 1? All right, well once you see the end result, you're going to say, okay, this makes a little bit more sense, so try and stay with me. All right, so instead of f of x, I'm going to write y. So y is equal to 2x plus 1. So I just took away the function notation. Now, if I want to find the inverse, your first step is to switch x and y. Because if we're trying to find the inverse, that's what the inverse function does. It takes those x and y's and switches their place. All right? So we have instead of y equals, we're going to have x equals 2y plus 1. Okay? Step 2 is going to be solve for y. In other words, get y by itself or isolate y. So, if we want to isolate y, we're going to subtract 1 from both sides. So I started with x equals 2y plus 1. We're getting y by itself, so we subtract 1 from both sides. So we end up with x minus 1 is equal to 2y. Then we're going to divide both sides by 2. Now it's important to know we're dividing this whole side by 2. We're not just dividing x by 2 or 1 by 2. We're dividing x minus 1 by 2. So another way to write this is x over 2 minus 1/2 is equal to y. All right, I'm running out of board space, so I'm going to put step 3 over here. So step 3 is replace y with the inverse f of x. All right, so that's just notation. We're saying that this is the inverse of what we started with. So our answer is going to be the inverse of f is equal to x divided by 2 minus 1/2. And there's your inverse.